differentiate. We got three questions here, A, B, and C. In A, we got function e raised to something, a big function. And we know that when we have e raised to something, let's say u, and when we find its derivative from the chain rule itself times u prime. So tangent x over x square is like u. Okay, and then the derivative is itself e raised to tangent x over x square times u prime, derivative of tangent x over x square. Now we got derivative of a fraction. That means we need to use the quotient rule. When we have u over v and we want to find its derivative, u prime v minus v prime u all over v square. Okay, so let's copy this, e raised to tangent x over x square times, using this quotient rule, on the bottom is squared, x square is squared, x to the fourth. On the top, derivative of tangent, that's secant square x times bottom minus derivative of bottom 2x times the top. Okay, we are basically done, but let me write this correctly. We cannot multiply x and x square because this x is in fact angle of secant square. Okay, we sometimes write in this way. So then this is it. Okay, we can just leave here. We cannot do much. The only thing we can do on the top, we can just factor x out, but does not help much. So this is it. Okay, that's for part A. So let me go for part B. Okay, so we got in part B square root of cosine theta. Now we can rewrite square root as, okay, we can write as cosine theta raised to 1/2. Okay, it's the same thing. Then it's like u raised to some function raised to number. So when we use power rule, using chain rule, u raised to 1/2 derivative, that will be from the power rule 1/2 u 1/2 minus 1 negative 1/2 times u prime. Now I'm going to apply this. So u is cosine theta. So the derivative here is 1/2 cosine theta raised to 1/2 minus 1 negative 1/2 times, maybe we can finish in one line, times u prime means derivative of cosine theta, that is negative sine theta, and we are done. Okay, we might want to write in better form, but this is it. Pretty much you may leave here. The best we can do is bring negative sine theta to the front, so negative 1/2 sine theta, or negative exponent, maybe we can put on the bottom with 2. If you want to do that, then sine theta can be put on the top, and this is 1/2 cosine theta raised to 1/2 on the bottom. That positive 1/2 becomes square root on the bottom. Okay, a lot of times this answer is enough. The best we can do is this. Let's do part C here. So we got sine square x square. Sine square, this we can rewrite. Okay, let me write here. This is in fact sine x square as angle, and this square means this quantity square. So pretty much it's like u is squared. Okay, so you can think like u squared. If you assume inside this whole thing as u squared, and we know the derivative of u squared, that is 2u times u prime from the chain rule. So I'm going to do that. Okay, so that is in our case, so f prime is 2u times u prime, where u happens to be sine x squared. Sine x squared. Okay, now next we need to work on this prime because we are not done. Prime means we still need to do the derivative. So this is, let me write over here. Maybe let me give me some room. This is 2. Okay, we don't need this bracket anymore. Sine x squared times, because sine x squared, this is not only x, so sine of something other than x, again we need to use the chain rule. Okay, we have sine of u, and when we find its derivative, that's cosine u, derivative of sine is cosine, times from the chain rule u prime. So we need to do that as well. Now our new u is x squared. Okay, so derivative of sine is cosine x squared times derivative of x squared is 2x. You may leave here. The best we can do is bring 2x to the front, that becomes 4x, and just write, there is no other, so I'm going to leave here. Final.